This lecture is going to be an overview on mixing consoles, including gain structure and signal path through the mixer. This is going to be more of a theoretical lecture since we are not together having a hands-on demonstration of the technology. Mixing consoles come in a number of different sizes, from the very small at the lower middle part of the picture to the very large on the right-hand side of the picture. The right-hand console by Solid State Logic has about 48 channels, whereas the little tiny one in the middle has only 3 channels plus 1 output. Mixers come as a combination of modules arranged and configured in a specific order so the incoming sound sources can be processed and distributed with a minimum of added noise and distortion. Console configurations are usually indicated with numbers separated by the letter X. For example, a 4X1 is a mixer with 4 mono inputs, meaning there's just one input per channel, and 1 mono output, also known as simply a 4-channel mono mixer. 8x2 or 8x2 is a mixer with 8 mono inputs and 2 outputs. This is also called an 8-channel stereo mixer, since the 2 outputs function as left and right outputs, and you would mix the mono inputs to the output channels. A 16x4x2 mixer has 16 mono inputs, 4 group outputs, which are mono, and a stereo output pair. This is also called a 16-channel stereo mixer, and we'll learn more about the group outputs in a later part of this lecture. 24x24x8x2, at this point we're stepping up to either a live sound or a recording studio mixer, and it has 24 combination inputs and direct outputs, 24 return, record, or monitor inputs, all on the same channel strip, 8 group outputs, and a stereo master output. And this is also called an inline recording mixer, meaning that it's inline between the input and the output of a 24-channel recorder. A 32x16x3x8 has 32 mono inputs, 16 group outputs, stereo master output plus a mono master output, hence the 3, and 8 matrix outputs. And this is also called a 32-channel live sound mixer. The console is divided into different modules, and the typical stereo mixing console, which we will review in this lecture, consists of 5 modules or sections: the input channels, the routing, the subgroups, the masters, and the monitors. Starting with the input channel, the first thing we look at is the gain structure. In order to get audio processed from the input to the output with the least amount of distortion and added noise, and remembering distortion is changing the signal in an unwanted, usually unwanted way, and added noise, and that occurs when the signal-to-noise ratio is smaller, it is mandatory to follow some standard operating procedures to control the gain structure. It is essential to understand some basic fundamentals related to gain structure. First of all is the headroom, and that's the difference between the nominal or peak level and the maximum output of any individual piece of audio equipment, and unity gain. The desire is to maintain a standard of unity throughout the entire signal processing chain, meaning if we were to put VU meters throughout our mixer system, we would try to have everything set so when all of the controls are set to their nominal or normal level, there is unity gain through the system, meaning we are not increasing or decreasing the level of the signal. Now, the input channel is basically divided into 4 parts: the preamplifier, the tone control or equalization, the auxiliary sends, and the routing and mixing. Now, to describe a little bit of those, just so you have a understanding as we move forward, the preamplifier is what's going to preamplify the signal of the microphone or the line input to get us up to that unity gain level through the input channel portion of our mixer. The tone control section is just like the tone controls, which you've probably seen as treble and bass or high and low, that will allow us to adjust the frequency content of our signal. And we have a little bit more control than just treble and bass or high and low in a mixing console. The auxiliary sends are typically used in a recording or a live application to send signals back to the musicians, either through headphones if we're doing recording, or through in-ear monitors or floor monitors if we're doing live sound. And then the routing and the mixing is the portion of the mixer that allows us to control the levels of the signals being sent to the aux sends and to the stereo main left and right outputs, or the 16 or 24 or 8 or 4 outputs that are going directly to our recording device, either a tape deck or a digital recorder. So starting with the preamplifier section, the preamplifier is where the inputs are connected, and most consoles have both a mic level and a line level input. This is at the left side of the diagram you're looking at in the lower left of this picture. The input gain levels are controlled by variable potentiometers, and those are the arrows inside the triangles in the about a third of the way over of the picture at the lower left, the schematic. The signal is generated by a microphone at a 1 millivolt level and is generally about 1,000 times weaker than a line level signal, which is approximately 1 volt. The 20 dB pad, which you can see in the microphone level, should be used only as a last resort if you cannot turn the microphone gain down far enough to bring your level within nominal levels, because adding the pad is a resistor network, which is represented by those 2 rectangles on the lower left corner, and adding resistors to your signal and lowering the level will add noise and or distortion to your signal. Looking at the picture over on the right-hand side of the screen, as you can see, the gray knob next to the word line represents the arrow in the triangle for the line level adjustment, and the pink knob at the bottom represents the gain for the microphone triangle at the bottom. You would typically use one or the other, and then the buttons on the right side, flip, is used to select between line and mic input, since you can only use one or the other at a time. The HPF is a high-pass filter, and that is usually used to high-pass, obviously letting higher frequencies pass through. It would be placed in the circuit if there was a very low-frequency rumble, such as if you were on a hard floor and every time somebody walked across the floor you heard a thump in the microphone, or if there was a 60 hertz, which is your line frequency for your power supply, a 60 hertz signal and introduced into the mic input. You could use the high-pass filter to filter some of that out. The 0 with the slash is your phase invert selection, and that you can see on the right-hand side of the schematic diagram on the left. And if you follow the signal, you'll notice that when the switch is in one position, the mic or line output is connected to the plus signal, and the negative side is connected to ground. And when you flip the switch the other way, it flips the plus to ground and the minus sign to the mic or line selector. That's how you flip the phase of an audio signal in your console. And in this diagram, you can see a number of components that we've previously discussed in the last section of the class. The next part that we want to talk about is the gain control and the line level adjustment. Those are the two triangles with the arrows inside them. Nominal levels depend on the manufacturer and the country. Typically 0.775 to 2.5 volts with systems that use +4 dBu level, and the average microphone output is 0.001 to 0.1 volts, which is 60 decibels lower than the nominal level. The gain control is an active process to add energy to either the line level or more commonly the mic level signal. And this gain control can be both your friend and your foe. It's an effective tool to bring the signal up to the nominal level, but it comes at the cost of adding noise and distortion to your signal. So you should always strive for the minimum level of gain to achieve the nominal signal level. The next section over on the right-hand side of our schematic where it says 2EQ is the equalization section. The EQ section consists of a number of different filters. It consists of high pass and low pass filters with variable cutoff frequencies and a fixed slope. It also consists of high and low frequency filters that act in a shelving fashion, and then high mid and low mid filters, also commonly known as parametric or sweep filters, and they typically have a bell shape. Now, to look at the image on the right-hand side of your screen, at the very top of the channel strip, you see the low and high pass filters. And if you notice the one on the upper right corner, just below the knob, it has a line that drops to the right. That is the low pass filter, and you adjust how much you want to cut or boost the low pass capability, and that's cutting frequencies at a very, very high frequency out of your signal. And the gray knob just to the left of that in the top section is your low pass. And if you notice, they've got frequency indicators on the one knob and decibel indicators on the other. The pink section is your high pass filter, and that is what's called a shelving filter, and that's what you can see in the top image on the left-hand side. If you look at it, it's listed as a shelving filter, and it says low pass and high pass. The pink knobs represent the right-hand side of that, whereas you can pick how much you want to cut or boost the high frequencies, and that's the left pink knob, and the right pink knob is at what frequency the center point of that cut or boost occurs at. On the bottom part of the screen, the gray knobs at the very bottom, that represents the same thing for the low pass filter, which is the left side of that middle frequency chart. The two green sections in the middle represent those parametric frequencies that we talked about, and if you notice, there are 3 knobs for each of those. The upper left green knob is the cut or boost knob, which determines whether that bell shape is going to go above the center line, or below the center line. The middle green knob on the right determines where that bell occurs within the frequency spectrum from 1 kilohertz to about, looks like 7 kilohertz. And then the third green knob, the bottom knob on the left, determines how wide or narrow the bell shape is. And these controls together will allow you to adjust the frequency response of the particular channel. Now, to understand the relationship between equalization and gain, equalization can cut or boost certain parts of the signal, and this can cause the level of these signals to rise or fall significantly from the nominal or desired level. This effect is more pronounced in the low or mid-range frequencies, since this is where most of the energy is concentrated. A typical error that recording engineers make is to adjust for the level discrepancies of a channel with the equalization. Boosting a signal with EQ reduces the headroom, and remember, headroom is where we get clipping if we hit the top edge of the power supply. Reducing the level at the fader after the equalization will reduce the signal to nominal levels, but at the expense of headroom. So it's important to reduce the overall level of a signal at the gain control, not with equalization. Detrimental effects of equalization includes with analog EQ, by boosting or cutting frequencies, you are introducing phase and impedance differences to the signal. Even when you've got equalization in the circuit, with all of the boost and cut controls set at their neutral or nominal settings, there is still a significant amount of electronics that are in the circuit, and they result in adding noise and distortion to the signal, even when no evident equalization is being performed. Therefore, if you look at the very bottom of the channel strip on the right, or the portion of the channel strip, you can see there's a button at the bottom labeled Equalizer On Off with a little light. When you're not using equalization, it is to your advantage to turn the equalization section of the circuit off, which means it will be bypassed. The next section of the input channel that we'll talk about is the aux and solo buses, the mute button, and the pan control. The pre-fader aux sends, obviously pre means before, so pre-fader controls allow you to set up a mix that is independent from the sliding faders at the bottom of the channel strip, and we'll see those in a few slides. The pre-fader aux sends are also known as fold-back, headphone, or monitor mixes, and these are used prior to or pre-fader so the performers can hear themselves regardless of how you, as the engineer, change the levels for the recording or for the live mixes. Now beware, though, that some systems, when you mute the channel, it does not mute the pre-fader aux sends. So wherever those are coming out in the output of your system, they will still be heard. And this becomes important if you're doing live sound and you have loudspeakers on the stage. When you mute a channel, you will still hear those outputs coming out of the stage speakers, and this is sometimes undesirable. The other type of aux send is the post-fader aux sends, and these are also called after-fader or effect sends. These are used not for musicians wanting to hear what their own instruments sound like, but if you're sending the audio from a particular channel to a reverb unit or another external effect unit or external equalizers, you do not want the signal to be sent to those processors if the fader is turned down. So the post-fader aux send is set, the level is set by the fader itself. The higher the fader, the louder the sound being sent to the effect send. As the note says here, beware that since these levels are affected by the fader, you should not use post-fader aux sends as foldback or monitor sends to the musicians, because it is very distracting to them to have their levels increasing and decreasing in their own earphones or monitors as you adjust the level of the faders. The remainder of the channel strip consists of the mute, solo, pan, and fader itself. The mute switch is used to disconnect the channel's signal from any of the mix buses, aux buses, or other outputs that receive the signal after the channel fader. Remember, this may not affect the pre-fader outputs. Channel buses and outputs are which pre-fader are not affected by the mute switches. The solo or Q switch can function in two different purposes. One of them is called solo in place. The other one is pre-fader listen. And when this button is configured, depending on your console brand and console purpose, as a solo in place, the circuitry automatically mutes all other channels to all outputs except the channel being soloed. This should not be used while in a mixing setting of a live concert or during multi-channel recording, because it turns all of the other channels off. The solo Q switch could also be set up in the pre-fader listen or PFL mode, and this is typically used, this is probably the more common use, and it's used in both live sound and recording. And pressing this button mutes all of the other channels, but only in the local headphone or monitor output for the recording or live sound engineer. The mix at all of the other outputs is not affected. PFL is very convenient for being able to either set individual levels during a sound check or isolating one input during a recording or a live show. For example, if you're getting feedback or you're hearing something strange, you can individually solo each of the channels until you find the problem, and then you can deal with that problem. And the pre-fader listen is not affected by the fader level or the mute settings. The next knob that we talk about is the green knob, and that is the pan or panorama knob. And this is a rotary fader that takes the mono input from the channel and places it onto or into the stereo bus, which is 2 channels, depending on where the knob is set. When it's in the center position, the signal is sent to both left and right channels at -4 dB, and it's raised to 0 dB as you turn the knob all the way to the left or all the way to the right, which would put that particular signal fully left or fully right in your stereo mix. The bottom knob is the fader, and the fader is the thing that you typically see recording engineers moving during a recording session or during a live event, and that controls the overall level of the particular channel. And the reference markings on the fader indicate a scale from negative infinity, which for all intents and purposes is off, to about +10. In other words, the channel can provide up to 10 decibels of gain. And since the fader is passive, the gain is added to the channel before it gets to the fader, and it's typically called makeup gain. And in order to maintain that nominal level all the way through the system, you would set your fader at 0 when you're ready to calibrate your system. Now, to look at the next section, in the previous picture a few slides back, we looked at the input of the microphone and the line level up to the EQ, and now we're looking at the remainder of the channel after the equalizer. And what you can see is that +10 gain, which is the +10 that you see on the fader. And then you see the fader, which is the rectangle with the arrow. The mute switch, you can see, sets the output to either the channel level itself or ground when it's muted. And remember, ground sets our signal level to 0. And then to the right of the mute switch, you see the signal splits to the direct out, which would go to a recording device, for example. And then you've got your pan knob, which lets you pan the signal from left to right for your stereo mix. And then you have the post fader aux send. And if you notice, it's after the fader. And then you have another fader that can either be set to post or pre. And therefore you see the switch where you can select it to be part of the bus that shows up after the mute switch, or you can flip the switch and it picks up the signal before it goes through the fader. And then you have the straight pre-fader aux send. And remember, pre-fader is used for sending mixes to the musicians in their monitors, either headphones, in-ear monitors, or a speaker. And the post-fader aux sends send the signal to effect units such as reverbs and equalizers and so on. And then the pre-fader listen is that output that when the button is pressed, it allows the recording or sound engineer to hear the signal, to listen for issues in the signal, or to simply solo it so they can hear just that one instrument alone and adjust maybe the equalization for that channel, since this happens after the equalizer but before the fader. The next section we'll talk about is the routing bus, and that's those yellow push buttons to the right of the fader. In this particular case, this mixer has 8 pairs of stereo outputs labeled 1, 2, 3, 4, 5, 6, 7, 8. So 1 and 2 is a stereo pair, 3 and 4 is a stereo pair, etc. And then the last one is LR. And LR would be your main output. The other ones would be stereo mixes for other purposes, such as stereo effect units. And as you look at the pan knob, the green knob, if it's turned all the way to the left, the signal from this particular channel strip will appear in the 1, 3, 5, 7, and L outputs. If the knob is turned all the way to the right, obviously it'll appear in the 2, 4, 6, 8, and R outputs. And then anywhere in between left and right, it'll appear as a combination for 1 and 2, 3 and 4, 5 and 6, 7 and 8, and L and R. Looking at the remainder of the routing, you can see those switches now splitting the signal to the 1, 2, 3, 4, 5, 6, 7, 8, and L and R buses. And then coming off of each of those buses, you have a summing amplifier and then the group fader for the individual groups, and then the left and right faders for the left and right groups. Those outputs are then buffered by the amplifier, which is the triangle on the far right, and then they show up at the XLR or balanced outputs on the right-hand side. So now to explain a little bit more about what those subgroups, which are the 1, 2, 3, 4, 5, 6, 7, and 8, and the master control, which is the master volume for the whole system. The subgroups in the master are where all of these buses come together, and each bus or each subgroup has its own master fader and physical output connector, plus each subgroup has a routing switch to connect the subgroup to its respective left and right stereo buses. Subgroups are used when mixing a complex set of inputs, such as a drum kit that might consist of 6 or 8 microphones, or an entire choir, which might have 8, 10, 12, 20 microphones connected to it. You want to mix those as a subgroup so you can then move one fader up and down to adjust the level of the entire submix or subgroup at one time. Here's an example of what that might look like. The choir here has, 2, 4, 6, 8, 10, 12 microphones. The drum kit has 8 microphones. And then there is a separate piano mic, a bass mic, and a vocal mic. So the choir mics are all mixed down to a subgroup. The drums are all mixed down to a subgroup. And then we look at the bottom. The engineer really only has to deal with 5 different faders instead of 1 fader for each of the microphones. And that's how subgroups are typically used. And that's primarily for live sound. In a recording session, you want to record each of those individual instruments so you can adjust their mix towards the end of the session when you're doing a mix down. And the last thing we'll talk about is a little bit more of an explanation on nominal levels and unity gain. Unity gain, again, is setting your system so you have a unity level or 0 level all the way through your system. So to start with, we use pink noise preferably. Sometimes some engineers will use a 1 kilohertz or 1K tone. And you start at the end of your system in this case. You adjust your power amplifier with the sound source plugged directly into it to a level of 85 dB SPL. Remember, 85 is the recommended level for a sound recording studio or live sound session. And you set your mixer output so 0 dB is read when you have a level of 85 dB SPL. And it's always better to push the signal instead of pulling it. In other words, do not turn your power amplifier volumes all the way full and then lower the output of the console from where nominal is to where you get the level that you need. And the reason for this is it seriously impacts your signal to noise ratio. You want to have everything set at the nominal levels, including your power amplifier. So position all of your input channel faders at infinity, which is negative infinity, which is also off. Adjust the master faders on the right-hand side of your console, typically on the right. Those are your left and right outputs and your different subgroup outputs. Adjust those all to the 0 level, which is nominal. And then one at a time, adjust each input channel using the following steps. Turn the channel input gain all the way down. Slowly raise the input channel fader to its 0 dB mark. And you want to do that slowly so you don't overload or distort your system or blow your speakers. And then when the channel fader is at 0, raise the input gain until the signal on the output meter reads between -10 and -4 dB. And this is usually in the yellow section of the meter. The lower part is green. The middle section, -10 to plus or -4, is usually yellow, and then it turns red above the -4. And then mute the channel and repeat these 4 steps, A through D, for each of the channels of your mixer with the known level pink noise. Alterations to the nominal channel levels by equalization should be counteracted by the changes to the channel's gain level. If you remember, you use that to re-achieve your nominal level, not moving the fader. And then when you're using the system, all of your faders will live right around the 0 mark, and you will slightly move those up or down as needed during either the recording or the live sound session. And that's it for this lecture on mixing consoles, signal flow, and unity gain.